Good morning. My name is Suzanne Ryan, and I'm with CCFM staff. I'm going to be the moderator today to kind of keep us on track. I'm going to be passing around an attendance sheet. If you need AIA credits, please list your AIA number and make sure that your email is legible. If you do not need AIA credits, we still need you to sign in. We will provide a certificate for attendance at the end. So in order to stay on track today, I'm going to be giving a 5-minute warning and a 2-minute warning at the end of our session. And we're going to try to save questions until the end if possible. All right, everybody set? I'm going to go ahead and start this right down here. Welcome to session COV2504, Restored in Christ, St. Mary Basilica of the Assumption, Historic Preservation. This course is 90 minutes and is certified for AIA for 1.5 learning units, HSW, Health, Safety, and Wellness. Our speakers are Brandy Ash with SHP Architects, Justin Walter, Tim Purdy and Todd Zapp with Trisco Systems, and Brendan Walsh with TrueScan. Please see the back of your conference program, pages 9, 13, and 14 for complete bios. So we're going to go ahead and get started.
Thank you. We'll try to leave a little time for Q&A today, but we have a lot of material to cover in 1.5 hours here. So thank you for the opportunity to be here today to share the preservation effort to preserve the Cathedral Basilica of the Assumption. Historic churches can be found across the country, often located on prominent street corners. They are deeply woven into the fabric of our communities. These sacred spaces not only preserve our architectural heritage, but also hold generations of memories from special services, weddings, and memorials. The cathedral is far more than a historic structure. It serves as a cultural and spiritual cornerstone of our community. Today, we're proud to share the story of how the Diocese of Covington made a significant investment to preserve the cathedral. It's a reminder of what can be achieved when a community cares deeply about its history and its future. My name is Brandy Ash, and I am a partner and the Director of Architecture at SHP. During my 27 years at SHP, I've had a privilege of working on a wide range of projects, but few have been more personally rewarding as the preservation of the cathedral.
Yeah, my name is Tim Purdy. I'm an account manager with Trisco Systems. Account manager is responsible for estimating and also customer relations with the customer. If you were to call our office with an issue or any kind of complaint with your building, our secretary would direct you to account manager, and we'd be assigned to your project. You'd get hold of us, and we would come and see you, see what your issue is, and try to resolve your problem.
My name is Justin Walter with Trisco. I've been with the company for about 15 years and currently serve as our sales manager, overseeing the sales, marketing, and estimating departments. Our team consists of about 5 or 6 members, including Tim, and our primary responsibility is to feed the machine, managing everything from the initial customer inquiry to the signed contract, at which point Todd and his production team and my dad's group step in to execute the project.
Hello, my name's Todd Zapp. I've been with Trisco for 43 years now. I started in the field as an apprentice and worked my way up to a project manager and currently a part of the safety department as well. So, and I am the project manager on this project.
Hello, my name is Brendan. I'm the owner of TrueScan. We're a team of surveyors, engineers, and architects that specialize in building documentation. Our work takes us all over the nation. We use a combination of survey equipment and reality capture processes to document all aspects of a building's architectural, structural, and mechanical systems. And I'm very grateful for the opportunity to be here talking today.
SHP is a nationally recognized architecture firm with a proud history dating back to 1901, which just happens to be the same year the cathedral was dedicated. I lead an incredible team of 115 architects, engineers, and interior designers. Our work spans 28 states and includes a diverse portfolio of projects from historic preservation, education, community, and commercial spaces.
I'll introduce Trisco on behalf of the team here. We've been around for a long time. We're the contractor on this project. We got our start back in 1936. As the story goes, my great-grandfather came over and was a self-taught chemist who created a product called Marble Tex, which was basically a fake marble product. Like a lot of people, he lost everything during the Depression, and a local businessman gave him a job in his shop. It was there that he learned about a leaky school building, so he concocted a solution that you could apply to masonry walls to waterproof them. We think the name Trisco was German shorthand for the chemical formulation. We went around the company back in the day and still do, applying the Trisco waterproofing system to buildings as far as New Mexico and Bermuda, as well as up and down the East Coast. Today we're a fourth-generation company with a lot of great people on our team. We've evolved with the industry as a full-scale restoration contractor. We work on all kinds of buildings, not just churches. So we'll do, masonry, concrete, eaves, historic and modern, working on schools, churches, parking garages, stadiums, office buildings, hospitals, and so forth. We care a lot about what we do, and we're proud of the relationships we've built. I think this team will show that today in our presentation. There's some people in this room that we've worked with in the past, folks from the Cleveland, Columbus, and Cincinnati dioceses, as well as a few projects over in Indiana. That's a little bit about who we are. Brendan will tell you about TrueScan.
So TrueScan has been around about 14 years. We started out as the division of an engineering and surveying company, and 2 years ago we broke out on our own. I'm the proud sole owner, which is incredibly exhilarating and terrifying at the same time. We are the largest dedicated reality capture firm in the nation, meaning we only do building documentation. There's other firms that have capabilities like ours, but it's all we do in and out every day. Each year we complete 200 to 300 projects. We document schools, churches, hospitals, stadiums, any type of structure you can imagine. We're called in to create existing conditions plans. We travel across the nation, and our work carries us pretty much everywhere you can think of. Brandy originally called us in because of our relationship, and this project was really rewarding to be a part of.
Before we begin the presentation, I want to thank everyone who has contributed to this project. First, I'd like to thank the entire Diocese of Covington and their parish community for their unwavering commitment to preserving the cathedral. Their dedication to investing the resources needed ensures the cathedral will remain a part of our community for generations to come. I'm also incredibly grateful to the Diocese for giving us the opportunity to be part of such a meaningful project. It has truly been an honor. A special thank you goes to Don Knockelman and Father Mayer. Their time, leadership, and ongoing support of the project and our team have been instrumental to the success of the project. Thank you to our incredible partners, consultants, and craftsmen who have brought their expertise, care, and dedication to every step of the process. Thank you to the incredible team at SHP. Their dedication, talent, and commitment made this project not only possible, but exceptional. And thank you to all of you again for being here today. This presentation will explain the comprehensive approach taken to assess, plan, and restore the historically significant Cathedral Basilica of the Assumption. We will focus on leveraging technology, the analysis required for a complete building condition survey, aligning preservation goals and long-term planning efforts, and the execution of the current preservation project. The cathedral's historical significance is the essential starting point of this story. The Cathedral Basilica of the Assumption was the vision of Bishop Camillus Paul Mays, appointed bishop of the Diocese of Covington in 1884. Bishop Mays had a vision of building a grand cathedral in the city of Covington. Planning for the cathedral began in 1885, and in 1890, Bishop Mays purchased a property at the corner of 12th Street and Madison Avenue. At that time, the location was considered to be the center of the city of Covington. Drawing inspiration from the Gothic cathedrals of Europe, Bishop Mays commissioned architect Leon Kaka of Detroit to bring his vision to life. The cathedral's interior design was influenced by the Abbey Church of St. Denis in Paris, France. The groundbreaking ceremony for the cathedral took place in 1894. Bishop Mays laid the cornerstone on September 8, 1895. The cathedral was designed with a rib-groin vault structure, which made it possible to achieve the impressive height and wide-open spaces typical of Gothic architecture. Large blocks of Bedford, Indiana limestone were brought to the site by horse-drawn carts and lifted into place using a system of pulleys and winches. By 1901, the nave, apse, and transept had been completed. However, funding for the cathedral had been exhausted, and the building was officially designated for use on January 27, 1901. Due to limited resources, the main facade and stained glass windows remained unfinished. Instead, a simple brick wall and temporary plain glass windows were installed to enclose the structure. The final design for the main facade was completed in 1908, drawing inspiration from the Notre Dame Cathedral in Paris. Once adequate funds had been secured, construction resumed. The cathedral's 82 stained glass windows were crafted in Munich, Germany. Among them are 2 rose windows, each measuring 26 feet in diameter, and the north transept window stands as one of the largest stained glass windows in the world. Construction on the cathedral continued for more than 2 decades, ultimately ending, still unfinished, in 1915. In 2019, Bishop Roger Foys initiated a plan to honor Bishop Mays by completing the cathedral's facade. To support this effort, the Diocese of Covington launched the Speaking for Centuries campaign, which successfully raised over $250,000 in donations. These funds were used to complete the tympana reliefs and the statuary for the main facades, portal jamb niches, and buttress niches, all elements originally envisioned by the cathedral's architects. 24 statues were commissioned for the project. 4 of the statues and the buttress niches represent the patrons of the Diocese of Covington: St. Thomas More, St. Paul the Apostle, St. Peter the Apostle, and St. Elizabeth of Hungary. The 20 statues placed in the portal jambs honor the patron saints of Covington's 47 parishes and diocesan institutions. The 2 tympana bas-reliefs completed the tripart portal scheme. Bishop Foys dedicated the complete facade of St. Mary's Cathedral Basilica of the Assumption on June 6, 2021. The preservation of historical buildings like the cathedral is crucial to our future. These structures serve as tangible links to the past, offering insights into the people, events, and traditions that have shaped the world we live in today. For the Diocese of Covington, the cathedral stands as a powerful symbol of their rich heritage. It is a living testament to the values and the faith that continue to influence the diocese today. In the fall of 2019, I attended a meeting at the cathedral to review the condition of the chimera statues. During this site visit, additional issues with the stonework were identified, leading to the suggestion and the necessity for a comprehensive building condition survey. Unlike gargoyles, chimera are purely decorative figures that do not serve a functional purpose in water drainage. When the main facade was completed in 1910, 26 chimera statues were placed at the top, encircling the roof parapet. 25 of these chimera are exact replicas of the original chimeras found on Notre Dame Cathedral in Paris. In 2018, Stephen Ensweiler, the cathedral historian, conducted a thorough analysis and a historical review of the chimera, carefully documenting the condition of each one. His report highlighted the physical damage accumulated over the years, such as missing shoulders, forelegs, and cracking throughout. One of the chimeras had also been struck by lightning and destroyed. In the 1980s, a series of tornadoes swept through Covington. In response, an attempt was made to preserve the chimera by installing steel brackets for support and filling them with concrete. However, this well-intentioned but misguided effort ultimately accelerated the deterioration, leading to increased cracking and damage. In 2001, the cathedral underwent a significant renovation, both inside and out. As part of the restoration, the architect developed a comprehensive restoration package that included epoxy injections to reattach the separated terracotta components. Trisco Systems carried out the restoration using specialized injection resins and adhesives to rebond the fractured elements, patching of the damaged sections, and reglazing them with a breathable coating. During my visit, one of the sculptures was being stabilized with ropes to secure it to the parapet. It was evident that the chimera could no longer be preserved in their current state, and a long-term solution was necessary. At that point, SHP engaged TrueScan to explore the possibility of using laser scanning to document the chimera while they were still in place. We began investigating the terracotta material used in the original sculptures to determine whether accurate reproductions could be made. This led us to contact Boston Valley Terracotta in Buffalo, New York, where we initiated discussions about the replacement process. While on the roof inspecting the chimera, we also observed deterioration in the limestone tracery at the tops of the towers. The type of deterioration we saw can result from a combination of factors, including the use of carbon steel pens, weathering, freeze-thaw cycles, environmental degradation, and improper past repairs. One of the primary causes of failure was the use of carbon steel pens, a common construction method used during that era. In historic buildings, these pens were used to anchor limestone, but over time, they tend to corrode when exposed to moisture and environmental conditions. As the steel pens rust, they can expand, creating pressure that leads to cracking and spalling of the surrounding stone. This hidden corrosion is often the leading factor in limestone failure on historic structures. After taking some time to review the exterior of the building, we recommended conducting a comprehensive building condition survey to fully evaluate the entire structure. A building condition survey typically involves performing a visual inspection and assessment of the building's physical condition, identifying any defects, damage, or maintenance requirements. A thorough building condition survey is a vital part in planning and executing future maintenance, budgeting for repairs, and gaining a clear understanding of a building's overall state. SHP was commissioned by the Diocese of Covington in the fall of 2019. However, due to COVID-19 pandemic, the survey could not commence until October of 2020. The building condition survey included the use of laser scanning to develop the building's elevations that could be used for field observations, developing a notation system to document the materials and types of failures observed, conducting a comprehensive building survey over the course of 1 week from an aerial lift or crane, providing final report outlining the observations made during the field survey regarding materials, current conditions, and treatment recommendations. The final report outlined a strategy based on the condition survey to inform the future project based on the most critical needs. Accurate drawings are an essential part of documenting existing conditions during fieldwork. SHP reached out to TrueScan to provide the digital building documentation that would be necessary to support this process. Today, Brendan Walsh is here to explain how digital building documentation can be leveraged to enhance building assessments, design, and facility planning. The scanning process or the observation process? Oh, we're going to get to a timeline on that, but yes, I'd say we started in 2019 was the first time I was there, finished the assessment in 2020, and we're doing the work now. So it's been quite an adventure.
One other question for context. My guys are here, like we have here, same problem here.
We do have Urban Review Design Board here in Covington that is really all about preservation. I will say we followed, and we'll get to this, the National Park Service standards for preservation. A lot of cities and states have adopted those guidelines. But no, I will say the city of Covington, they didn't really, Don, you can speak to this, I don't think they got involved much at all, other than we did submit a permit, but, everything we were doing was really true to what they would have wanted us to do. That's all right.
Thanks, Brandy. So initially, we were called in to document the Chimera up top, and despite growing up in Cincinnati, I never knew this church existed. But when I saw it, I said, I got to scan this. This is beautiful. Within a month of us scanning this church, the big fire broke out at the cathedral in Paris. And if you're familiar, the restoration was heavily enabled by the fact that another person over there saw the church and thought, I got to laser scan it. So it was really cool that that happened. It was really cool that we were able to document it. So we specialize in reality capture. Reality capture is the process of capturing existing field conditions and storing them in a digital format. It can be as simple as taking a cell phone picture and putting it in the project folder, or it can be as sophisticated as using survey equipment, sonar, ground penetrating radar, GPS, to capture field measurements and then converting them into AutoCAD deliverables or PDF floor plans or 3D models. Reality capture is beneficial to projects in a lot of ways. Speed is one factor. The laser scanning equipment that we used on this church captures 2 million points every second. If you can imagine a team of people taking notes by hand, it would take ages to capture 2 million points. Our equipment does it every second. Accuracy. If you've ever tried to go out and measure a building by hand with a tape measure and a notepad, accuracy is incredibly hard to achieve. As a surveyor, I have measured hundreds of buildings by hand, and I've never gotten one of them to close. It's hard to make accurate measurements, and it's hard to decipher the field notes when they come back to the office, even if it's your own chicken scratch. Reality capture simplifies complex scenes. It paints a really detailed picture of what you've got in the field, so it minimizes the interpretation that it takes to convert those measurements into deliverables when you're back in the office. And it increases safety. Historically, building facades have been documented by putting people in scissor lifts or in cranes or on scaffolding. A lot of companies around town use teams of rappellers to rappel down over the side and get their hands on. Those processes are not only expensive, but there's an inherent safety factor. So reality capture presents a number of benefits. If you've ever tried to document a building by hand, you typically fall into one of two scenarios. The first one on the left is where you have existing conditions plans. A lot of buildings have plans. They're usually curled up in the basement and they're pretty dusty. They're either incomplete, inaccurate, hard to read, or altogether non-existent. The other scenario is that you don't have any plans at all. Either way, you're out in the field, you're taking measurements, you're trying to jot stuff down. There's no way on earth you're ever going to measure everything in the field, and there's no way on earth you're going to paint a clearly comprehensive picture of what you captured when you get back to the office. So our process just speeds it up, makes it more efficient, and adds a lot of value. So this is a quick video of how a laser scanner works. A laser scanner basically emits a beam of light, just like a laser pointer, if you've ever used a laser pointer. The light leaves the instrument and returns, and it measures how long it was gone. It couples that with a horizontal angle and a vertical angle to get an XYZ coordinate. It does that a couple million times a second. Now, the laser scanner can't see through things or around things, so when it's done painting a 360 picture, you've got to move it so that you can get good coverage on all facets of your object of interest. Once you get your field data done, you bring all that information back to the office and compile it through a process called registration, and your final output is a point cloud. The point cloud can then be brought into a drafting software like AutoCAD or Revit or SketchUp, whatever you use, to start drawing your floor plans, your elevations, and your 3D models. Because the instrument is shooting a beam of light, There's a lot of factors that come into consideration. Beam divergence, so light gets further out as it travels. Think about your flashlight. If you put a flashlight against your hand, the beam's really small. If you shoot a flashlight against a wall, the beam's really big. If you shoot a flashlight directly at a wall, you get a good return. If you shoot at an angle, you get a lot of refractance. Things like your angle of incidence, your distance, your material property. Lasers don't do really well on shiny things, stainless things, mirrors, glass. All these come into play when you talk about setting up a laser scanning job, because everybody wants to know how accurate it is. All these things kind of play into the error that you get. On the right here, you see a cross-section of the point cloud. All the little bubbles are places where we set up our scanner. So to design a laser scan, we first think about control. So survey and control was brought into this project. It functions in two ways. Number one, it serves as an independent check that our laser scan data is good. No matter what kind of measurements you're taking, it's always important to check them. Survey control also allowed us to put the point cloud data onto real-world coordinates. And we're trying to think about future use and future value for the project. If the diocese ever wants to come back and do civil site work, change a sidewalk, replace a sewer line, the laser scan data can be used for all sorts of applications if it's able to be referenced. The laser scanning field work, since it is a line of sight instrument, we set it up about every 10 to 15 feet throughout the church, inside and outside, to get good coverage on all the facade elements and all the internal geometry. We try to maintain about 30% overlap. So the scan data comes out radially from the instrument and has to be married together through a process called registration. The further apart your scans are, the more error you can have. The closer together they are, the tighter your registration is. We then bring all that data back into the office for quality control and post-processing. Now, because it's a line of sight instrument, there's a lot of places on the rooftop that are out of sight. There's also places that are obscured from sight behind a buttress or behind a cove. So for this particular project, we deployed our unmanned aerial system, also known as a drone, to take photography and aerial LiDAR data, which supplements the measurements we can take from the ground, because our scanners sit on a tripod. There's only so much you can do from 5 feet off the ground. So we bring the drone data back, we bring the terrestrial data back, and we process that all together through registration. We apply our quality control, and our output is a point cloud. Now, the point cloud is brought into a drafting software. We use Revit, which is pretty much the architectural standard these days, to produce floor plans, elevations, and 3D models. Revit makes it really simple. You bring the point cloud in, you cut a slice, and you start to trace. We start with setting our levels. Basically, when you set a level for each floor, it gives you your floor-to-floor height and gives you a relative difference from the ground. We then model out the shell and the core components of the building. We model the structure, and then we move into the geometric details. There's two major governing bodies that we abide by, the U.S. Institute of Building Documentation and BIM Forum. The U.S. IBD sets standards for measured and represented accuracies, so these are ranges. So if you're using a tape measure, that might be good enough. If you're using a laser scanner, that might be good enough. The U.S. IBD sets these ranges so that you and your client and the owner can have realistic expectations about what's going to be done. BIM Forum has produced specifications that guide level of development. So when you're building a building model, there's a lot of different effort you can put into how good the model is. Does it look like a cardboard box that my kid drew? Or does it have all the nuts and bolts and doorknobs and hinges and outlets on it? BIM Forum specs kind of guide that development process on how good is good enough. So when we get our point cloud into Revit, we cut a very thin slice and we trace the walls. It's a really manual process. There are some automated software out there, but other than piping, we don't really rely on them. We trace our walls, we trace our columns, and then we do our interior partitions. All this is done in plan view for each floor independently. Once the 2D top-down is done, we move into the vertical. And this basically involves extruding the walls from floor to ceiling. We have those levels set, we have those heights. Then we can cut in our windows, we can cut in our doors, we can apply horizontal elements like beams, trusses, joists, that kind of thing. And we can also detail out facade elements, windows, mullions, louvers, to give the model that realistic look and to give it architectural accuracy. We also took a series of vertical photos on the facade and married these together in a process called photogrammetry to produce a vertical orthophoto. Because the orthophoto is rectified and accurate, you can bring it into your drafting software, align it behind your line work, and trace the facade elements. You can trace the masonry elements, you can trace the organics, you can trace the plaster reliefs. Having these detailed photos was really helpful in making the model much more lifelike. So for our final handover to Brandy's architectural team, we created a model that was not only survey-grade accuracy, but architecturally realistic and had all of the detail inside and outside that they would need to plan their restoration. I kind of went through that quick. Does anybody have any questions for me?
So how do you charge for this service? Like, is it just time and materials? Is there a basis? Like, how do you approach this?
It all depends on the project and the intent. So there was a lot of conversation about what they were trying to do, and the pricing is really a conversation.
All right.
So when you're trying to put something like a built building into Revit, where Revit wants to be very rectilinear and perfect, and you know, an existing building where it wasn't quite built perpendicular or where your wall might not be vertical, how do you deal with conditions like that and documenting that?
That goes back to those USIBD specifications. So depending on the range that you're in, you have an allowable tolerance of how close you need to be. Because you're right, Revit is not real friendly in that regard.
It is not real friendly in a lot of regards. Yeah.
In this information that we get from you, we need a deliverable release from the architect.
Yeah, I'm going to kind of show you yeah, there's still a lot of setting up, but what Brendan does very much forms the foundation for what we need to do our work in the absence of any drawings, or I don't think we had a lot of material. Yeah, there's still work to be done.
Yeah, at the end of the day, we measure what's there and they design what's next.
So as Brendan mentioned, he did hand us over a Revit model that was very detailed, but we had a lot of kind of next steps that we had to do with that information once we got it. So we created this building plan, you can see here, using his model, and we had to identify each elevation that was inside that building. And there are over 170 different building elevations involved here. So this is an example. Each pier return, each side of the buttress, and all sides of the spires had to be documented. And we had to go through and take that model and set up each one of these so that we had accurate elevations to record all of our field observations onto. So before we began our field survey, we developed a standardized notation system. This system used abbreviations to categorize common types of masonry deterioration and quantification of the failures during documentation. Some common examples of conditions to be noted during our field survey included areas with soiling on the building or biological growth. Open joints were noted to be repointed. Cracks were noted based on their size from 1/8 inch to 1/4 inch. Unit repair was noted where limestone units had lost material. Missing or cracked finials were noted to be replicated or repaired. Spalling in the limestone and terracotta were noted. Failing or poorly matched previous patches were noted to be replaced with Dutchman repairs. And cracks and patching in terracotta units were noted to be repaired or replaced. So we needed to kind of get all of this onto paper, so when we were up in the air, we had a clear system to mark our elevations with. In October of 2020, over the course of 1 week, we completed a comprehensive building survey. The survey was conducted using both ground-level observation and a lift. Because lane closures on Madison Avenue were not permitted, the highest sections were surveyed from a crane-mounted bucket suspended above the street. Detailed field notes based on direct observation were carefully documented onto the building elevations. These notes provided a comprehensive visual and written record of the building's current state. Observations included open joints at the spires, minor cracks in the terracotta tracery surrounding the stained glass, cracks and open joints in the limestone sills, open joints in the terracotta tracery, cracks in the terracotta units at the gable, areas of spalling in the terracotta, cracking of limestone units at the building corners. The final building condition survey was completed in February 2021. The final report outlined all field observations made using a combination of drawings and photography. The report included the documentation of all materials, the current conditions, extent of the needed repairs, and treatment recommendations. The report recommended prioritizing long-term repairs whenever feasible. Although these solutions tend to be more costly, they offer greater life cycle value and represent the most effective strategy for the diocese. For instance, a stone Dutchman repair will significantly outlast a simple crack injection. Another important factor was the cost associated with contractor mobilization and scaffolding. To maximize the value of those upfront costs, it was determined that addressing as much of the project scope as possible at once would be the most efficient. It was also advised that any repair materials should closely match the original materials rather than substituting them with modern alternatives. The detailed and comprehensive building condition survey was essential to the successful planning and execution of the project. The building condition survey was also fundamental in establishing the project budget. Upon completion, we reached out to get contractor expertise in order to develop an accurate preliminary budget for the project.
As our sales manager, I oversee the preparation of about $60 to $70 million worth of proposals each year. Of these, about 10% are preliminary budgets, I'll call them. So before Tim jumps into his section, I just want to take a few minutes to talk about some of the important things to keep in mind for a project like this. Since this is an educational course, I wanted to leave you with a few ideas you can take with you, things that might help when you're planning or budgeting your own projects down the road. We'll get into some specifics about what we did during the early stages of this project, but first I want to frame a few key points about budgeting, because how you approach the early budgets can really set the tone for the whole job. So let's talk about types of estimates. I kind of made up my own categories for this, but they'll give you a good framework for how to think about them. First up, the ballpark estimate. This is what we often get asked for right out of the gate. Hey, can you just give me a ballpark? Now, ballparks sound simple and casual, but they can actually be dangerous, because they're based on limited information, and because of that, they can kill a project before it even gets started. If I ballpark it at $5 million and it's really a $1 million job, it might scare everyone off. If I say it's a $1 million job and it turns out to be a $5 million job, financing could collapse. Then who's to blame? So on small, simple projects like a little gym or a rectory or an annex or a little bank building, a ballpark estimate might be fine. But on something as complex as the basilica, you really need more information, which is where I get into the conceptual budget. You have a rough scope at this stage, some preliminary assumptions, you start kind of painting a picture of the project. You're still not ready to put hard numbers to materials and scaffolding and things like that, but you're a lot closer than a ballpark. Conceptual budgets are good for getting the right neighborhood of cost, but there's still a lot of unanswered questions at that stage. Things like assumptions and allowances, how much does that stone cost? Let's throw in $1,000 a piece. You're just kind of winging it. And the numbers can really change once those details are developed through the process. So third, I get into the realistic budget here, which is how we approach this particular project because there was so much information available to it, to us. By this point, you have a relatively clear scope or a defined intent. You've thought through access, methods, scaffold, crane, whatever it may be. You've got a general idea of what materials you need, approximate quantities, sizes. You can start talking with vendors, getting some preliminary pricing put together, and really you can have a budget that's strong enough to present, to start securing financing, looking at tax credits or grants, finalizing designs, and really start moving the project forward through the bidding and contractor selection process. And then finally, I call it the firm proposal. After the budgeting, you got to get something you can actually take to the bank. So this is the contractor's real competitive bid, the number you write the contract for. By the time you get here, there should be no guessing left. The scope should be fully defined. Materials should be selected. Access methods are decided. You've got a plan in place. But one thing to remember, I say on this slide, if the scope isn't fully defined, contractors will build risk into their pricing so to protect themselves. So the more complete and detailed your documents are, as they were in this project, the sharper and more accurate the pricing will be. There's still going to be some things that change here and there once you get on the wall, and that's why we've established a lot of unit prices in this project. But if you got a detailed set of drawings and a lot of legwork up front, you're going to get a more dialed-in price. So, to set up what Tim's going to talk about, I want to leave you with a few questions that you and your contractor should be thinking about at these early stages. What are the numbers for? Are they for fundraising? Are they for budget planning? Are you trying to set realistic expectations or just start to raise awareness? When will the project happen? What happens if the budget's wrong? Are you dead in the water, or do you have a chance to revisit it? How comfortable is a designer? Some architects are very experienced with restoration. Others are new to it and might need more contractor input, or their drawings may be a little bit vague. And how serious is this project? Is it a real opportunity, or is it just a what if right now? All these things affect how seriously a contractor can and will approach the budgeting process. When we first got the call about this project, we had to think about all these questions, and we needed to know how much of the scope is design, who quantifies the repairs, the contractor or the architect, how long will this take to put together, who's developing the details, the contractor, the architect, the consultant, what materials are being used, has the existing materials been tested, are tax credits or grants involved. Another critical piece, especially on a project like this, is timing. We started work on this project back in 2019, and think about everything that's happened since then. 2 different presidents, a global pandemic, major international conflicts, tariffs, and supply chain disruptions. So everything from labor costs to material prices has shifted dramatically, and that has real implications for long-term project planning and budgeting. Who would have thought the number that, we gave in 2019 would go through so much between then and now? So you have to account for that kind of volatility when you're building a budget for something that might take several years to materialize. So ultimately, when you're asking for contractor input, you want to be clear about how real the project is and how much depth you need from them. Because putting together a good, detailed early budget takes a lot of time, energy, and commitment. It's not just a quick courtesy, it's a serious investment of resources. This is especially important to consider if the contractor is providing all of this as a courtesy or as a free estimate, because ultimately a lot of times they're going to have to still go bid that project competitively, as we did in this project. So the integrity of the contractor input is key. You need to make sure if they just did a drive-by and kind of winged a number at it, or if they put a lot of time on site to get you a reliable budget, and that they didn't just wing it. So fortunately, with this project, we had a great team in place on both sides who knew how to navigate these questions and these challenges. So Tim will tell you more about that, but I can tell you this, a lot of thoughtful, thorough work went into this early effort, and I think that's what made everything possible to this point. So with that, I'll turn it over to Tim so he can walk you through the early details of how we got into this thing. Click for you.
Brandy contacted me back in 2021. She's trying to put together a budget estimate for this project. I met her on site. She had drawings, very, very thorough drawings. I think she had around 20 operational repairs listed on the drawings, plus also on the elevations. Part of my job as an account manager, once she hands that stuff over, I got to get a feel and I got to get acclimated with the project. Part of that is taking a footprint or maybe even a roof plan of the drawing and walking it, which I know Brandon kind of rained on my parade because it's kind of antiquated the way I do it. I measure the walls. I measure the lengths and the depths and the lengths and the widths of the building, plus the elevations, because a lot of times just a height of an elevation isn't staying true to what's actually on the wall surface because all the ins and outs, especially on a project this thorough. I would take the work operations that Brandy had given me. I would analyze those. Oh, let me back up here a minute. It's a three-step process, a three-pronged process when I look at a project. The first one, I walk around, I get the dimensions, the elevations, and the heights. My second walk is to confirm her work operations and identify where they're at, sizes, shapes, and then also for me to see whatever else is on the building that she might not have picked up. So I'll make one trip with the dimensions, one trip with analyzing what the building looks like, and then my third walk will be to analyze the mortar joints in the building. What mortar joints are mismatched mortar joints? What mortar joints are fractured? What are deteriorated? If you got a bad downspout and it's raining a bunch of water on this wall, you know, you might have an area that's 5 feet long, 10 foot tall. So I would identify all this information, come back and put it all together. Also, what you got to consider too is if you're doing any element gets repaired. Here we got a column showing and also a spindle on one of the balustrades. For me to get accurate pricing, I need to provide that to my material supplier, and I need these to cut the stone to this shape, so my dimensions have to be halfway accurate. Although these are hand-drawn, they do get the point across of what we need, and also the quantity we also need to acquire from them. But as we go through, the drawings came out then later on for the bid, which was 2024. I think she changed the number of operations, might have become 25 operations at that point. And that could be anywhere from fracture repair to terracotta, the limestone. It could be a stone patch, terracotta patch, mortar joint replacement. This project was a very large project, and I need to have a level of confidence with me when I go back to the office and talk to my head estimator and tell him what we're bidding, what we're doing on the job. I have to be confident with what I'm looking at. I actually went through like 3 separate sets of drawings. I would take a set of drawings, I went through them, and that one, I just checked it out like a week ago, and one was take 1. Then the other set of drawings was take 2. The other set of drawings was take 3. I had to be confident knowing what I was doing and what I was looking at, because you look at a project this size, there's a lot of unique details on it that you don't see just at a glance. The other part of that too is I went back through and I counted about how many work items or work eaches. So when I say eaches, if we get the job, which we are lucky enough to get it, the eaches is where, I didn't tell my project manager this when I first got the job, but he's got to go up and do over 3,500 repair items on this project. It might be here, they might be all over the place. They're scattered all over, it's not one location. So that's a lot of operations, and also putting money and dollars on it and make sure that everything comes out properly. So again, discussing everything, the stone cost, the logistics too. I know originally Brandy had planned on putting scaffolding around the perimeter in the budget estimate so you could access every square foot of the wall. We typically use man lifts and also swing and stay scaffold, which is the stuff that hangs from the buildings with the cables and the planks. And that's how we're doing a lot of this work. Thank you.
Thanks. So based on the feedback that I got from Trisco and also some material suppliers that we had reached out to, and also a scaffolding company, we put together this budget for the diocese in August of 2022. There was a lot in there. Trisco's number, the Chimera replacement, the original ones, scaffolding. I know there was some work that the diocese that we weren't involved with for stained glass, they wanted to make sure got covered. We kind of applied some standards on there for hard cost and soft cost of work, and our final budget was $5,498,000. I also want to mention that the diocese engaged with Cumberland Ventures to assist in applying for Kentucky Historic Preservation tax credits for the project. The application was submitted in 2023, and in June of 2024, the diocese received their tax credit allocation. The value of credits received for this project was $1,169,400. $497. The construction documents for the masonry preservation of the facades began in August of 2022, while the fundraising efforts were ongoing. The project approach for the final drawings and specifications were based on the National Park Service Secretary of the Interior's guidelines for preservation. The Secretary of the Interior provides 4 standards for historic property treatment, categorized into preservation, rehabilitation, restoration, and reconstruction, each with its own guidelines. These guidelines help architects, contractors, and building managers make informed decisions before beginning their work. Defining the treatment standard early in the process is crucial to guide the project's direction. Many state and local entities have adopted the Secretary of the Interior's treatment standards. Aligning with preservation standards, the scope of the project was characterized by retaining original form and material, long-term integrity and maintenance. Sorry, I lost my place. The combination of the Building Condition Survey and preservation guidelines formed the foundation of the project. By defining the scope and working closely with the diocese on repair strategy, we developed a preservation plan that was grounded in the building's actual condition and aligned with the budget. Once again, a masonry repair schedule was created for the drawings, aligned with our field notes. The final repair schedule included a repair code and a unit of measurement and description for each type of repair. The team began by spending time on site documenting the building elevations at a greater level of detail. Field notes were carefully coordinated with the documents, and additional notes were added to convey the full scope of the work. Included in the final documents was a requirement for the contractor to include 26 different types of unit prices to be used for any unexpected conditions or additional repairs that may arise once the project was in progress. It had been nearly 3 years since the completion of the Building Condition Survey, and we knew it was possible that additional failures would be found. The unit prices provided by the contractor could be applied during construction to adjust the contract sum based on the measurement of individual work items. While finalizing the construction documents, the early procurement process for the Chimera began. During our early conversations with the terracotta manufacturer, we learned that the lead time for producing 26 Chimera terracotta statues could be as long as 1 year. Initiating the process early would allow for the units to be in production before the completion of the construction documents. Also, after discussions with the terracotta manufacturer, it was decided that the Chimera statues would need to be removed from the parapet and scanned on the ground. Once removed, the manufacturer requested that the units be shipped to their facility so artists could use them as a reference while creating the molds and carving their features. On March 16, 2023, the terracotta manufacturer conducted a scan of each Chimera while they were still in position on the roof as a preventative measure in case any damage occurred during the removal process. The Diocese of Covington then hired a contractor to carefully remove the Chimera and lower them to the ground. Once on the ground, the terracotta manufacturer performed detailed 360-degree laser scans of each statue before they were transported to their facility near Buffalo, New York. The inventory of the chimeras compiled by the cathedral historian, which included a comparison of photos between the Chimera of Notre Dame Cathedral and the Cathedral Basilica of the Assumption, was also sent to the terracotta manufacturer. The installation details were coordinated by the team, and shop drawings were generated from the scans supplied by the terracotta manufacturer for production and installation purposes. Some of the missing pieces from the removed terracotta, which couldn't be scanned, have been recreated by artists using historical photos of similar chimera from Notre Dame Cathedral as a reference. Several of the chimera are currently being produced, and the completed chimeras are waiting for the remaining ones to be finished before they are shipped. On February 6, 2024, an invitation to bid was issued to 7 qualified contractors. The team decided to base the final contractor selection on a balance of both cost and qualifications. The contractor was ultimately selected through a competitive formal bidding process, followed by an interview. The diocese received bids on March 6, 2024, with Trisco Systems submitting the lowest bid at the total cost of work, including all alternates, of $3,987,000. The bid came in below the original sum set forth in August of 2022. After receiving the bids, the Diocese of Covington and SHP conducted interviews with the two lowest bidders before making a final decision. The interview process provided the diocese and the architects with an opportunity to learn more about the contractor they would be collaborating with, as well as to ask further questions. Topics covered included the contractor's past project experience, implementation plans, staffing, site logistics, and the project schedule. Following the interviews, Trisco Systems was awarded the project and quickly began mobilizing to start work. The work began on site a little over 3 years after the building condition survey and conceptual budget were completed.
So implementation is Todd's area. I'm just going to kind of introduce him here. After what felt like an exhausting and relentless bid process with a lot of sleepless nights in preparation and working through presentations till into the early hours, Tim doing a takeoff 3 times over, I went down and had a couple meetings or walked the building myself. We finally got the green light. But then Tim and I were looking at each other thinking, now we actually have to do this thing. So we handed it over to my dad's group and Todd. And the first thing they said was, you told them we're going to do what to that building for what price? But before I pass over to Todd, I just want to touch on something that's been interesting about this project, the implementation process. As I mentioned earlier, it's our job on the sales side to feed the machine, and Todd's job on the production side to make it happen. This project's been somewhat unique. Typically, you have kind of a straightforward design, bid, build process. Architect designs it, we estimate it, they build it. This project has kind of become a de facto design-build project because it was and still is a back-and-forth effort of designing, pricing, and construction, which makes the point that cost should never really be the sole driver behind contractor selection, especially on a complicated project like this. You got to put together a team that can actually work together and communicate with each other through the ups and downs. It's not a project on our side, it isn't a type of project that I can just hand over and say, hey, go build it for this price, try to beat the budget. Tim's been involved in nearly every project meeting. At one point, I asked him why he was heading back down to Covington again, and he told me, don't worry, I know where I need to be. So I trust his judgment because this project's a big deal, and it requires that kind of attention, especially considering all of the things that we found once we started dismantling it, which Todd will talk about later. The process and collaboration has just gone around and around. As we've progressed, we've encountered a mix of good, bad, and unexpected challenges. Some areas have required more extensive work than we initially anticipated. Over the course of the 6 years, we've seen some elements worsen since the initial survey, but we've also found some that were in better shape than we expected. For example, one positive discovery was the condition of some mortar in some of the recessed areas that we originally had scheduled for replacement, but upon further investigation and tapping on and grinding and stuff, we found it was in actually pretty good shape. Additionally, we were concerned that the top 15 feet of this chimney way up there would need to be reconstructed, which is scaffold and cranes, and it's a major situation. But upon closer inspection, we realized that it was structurally sound and could be saved with helical pins and stabilization methods, which allowed us to shift some resources to other areas. So as we continue to move forward here, we uncovered some challenges that weren't immediately visible. The ugly, so to speak, was found beneath the surface, and Todd will get into that shortly. But for now, I want to transition to his part. While we're talking about what he's doing and some of the fascinating stuff, we got to really understand and appreciate what Todd's accomplishing out there, and I want to give kudos to him because it's, these are intricate repairs. They're unique solutions that require a high level of craftsmanship, and we're doing them 150 feet in the air, where safety is a major priority, and dealing with conditions that demand precise, calculated execution. So these challenges that are significant, but Todd and his team are navigating them with swagger. This type of work requires Todd's 40 years of experience. Take it away, Todd. That's your pointer.
Okay, they had, 3-4 years putting this project together with TrueScan, SHP, Tim, and Justin. So when they gave me the keys to the bus, they told me I had to do it in a year. So I said, okay, we'll give it our best shot. But when we move on this project, the first thing we got to do is start getting our mortar matching. We got to send it off to get tested so we get the right type of mortar that's compatible and the right PSI strength. So we're putting in the correct mortar per the historical preservationist guidelines. You need to get our stone guy in order. We need stone samples because there's a lot of stone detriments, which we'll get into, and a lot of stone replacements. So getting this correct stone match is very critical. So we got to get him on board. Then we got to start our stone templating. This is the contour of the stone, the profile of the stone, along with the radius of the stone. Because this project here has 32 traceries, I believe, and they look similar, but are they? So we went around and traced back of all of one, and then went around and checked every one. We found out that 10 of them aren't the same. So that was good thing we did that. Then you got to start on your shop drawings, getting them drawn up so we can tell Brandy and submit them where we're putting our pins in and all that, and get them to our stone guy, terracotta guy, and all that. Then we got to take a look at the tracer. We know there's a good bit of work up there, so we have to start taking a look at that. The glazing colors on top of the terracotta. We'll get into more what terracotta is here in a little bit. But the glazing colors, all this has like 2 to 3 to 4 week lead time. So this is the first thing we got to get started on. Get them sent out. If we don't get this back quickly, that's going to set the job back. So then we got to figure out our detriment methods. There are several different methods we got to do on this job, and we'll review that here in a little bit. The patching, even though we're doing patching minimal, anything under 2 inches we can patch, but the patching material matching is critical in our detriment repairs, which we'll review that as well. Then the cleaning process. We had to do cleaning samples. This wasn't really part of our project, but it was an allowance allowed for it. So first thing we got to do is go ahead. We tried 3 or 4 different types of chemicals in the processes to see who's going to give us the best results. So we ended up with what we thought was the best result. And the key thing with this is, especially this particular material, you don't get immediate satisfaction. You got to let the wall dry, sometimes up to a week to start getting the actual what you're getting into. So the next week or after that, we're up there getting documented existing conditions. Like I said, the 3-year span from when the job bid, to where they document it to where we get to now, there was some more changes made to the building. So we're up there documenting it, putting it on our plans, labeled and marked repair locations directly onto the drawings. So I'd label it on the drawings, take a picture of it, then identify it, send it over to Brandy so she knows exactly where that picture is on that print. I'm up there in the lift. I spent like a month going around the building, me and my foreman. Also, you can see here where we put that together. We put this tape to identify, hey, this looks a little more than just a repair. We might want to take another look at it. So then our stone guy, we got him on board. He's bringing us stone samples. Again, we picked this guy. We work with him quite a bit. This is not your basic stone project where you go down to the local stone guy. He cuts a square, a rectangle, maybe put a little pitch on it. This is a lot different. So we had to make sure we got the right guy for the job. Here's a picture of our templating. Right there, there, and there. That's just the, so we can get the diagram of the stone. You'll notice the holes here in that templating. I'm going to show you why that's very important as we go forward. Okay, here you can see these things are obvious. This was noted on the prints. You can see where the steel pin's blowing it out, as Brandy referred to earlier. There, so them are obvious to come. Them are visible from the surface. This is what's not visible from the surface. This comes from up in the upper traceries and or the balustrade areas. You can see all this fracturing here, but what you don't see is that fracturing on the outside. So this is what we found when we started removing some stone and saying, hey, we need to take a closer look at some of these areas. So you can see that at the crack repair. So when we removed that, you've seen that picture before. And over here, you see that piece broken right there. You see some cracks over here. And keep in mind that single column here, here, and here, yeah, that'll be important to you later in the.
What's important to note on this slide too, Todd, is like these right here were scheduled to be fracture repairs.
Yes.
You know, anywhere else on Earth, you know, you would first knee-jerk reaction is, you know, fracture repair.
Yeah, inject it with some epoxy.
Until you start seeing some of this business, you start realizing that, you know, there's more going on beneath the surface that's leading to these errors. They're not from the outside in. We're not doing this work to prevent moisture from getting in.
Right.
This is actually a bigger situation. And when you realize that these are, you know, structural elements, you can't just take that piece out.
Right.
It's holding up a lot of things.
So the items in blue are part of the contract. They were marked on the prints. We were supposed to put a Dutchman or replacement piece of stone there. So obviously we knew we had to take them 3 stones up above it off, so to replace that part in blue. But the parts in yellow, as I went around and documented, I'm saying we need to take a better look at these pieces because the deterioration has grown since the past 3 years. So we may want to look at all this a little differently now. Here's the balustrade area. This is after we tore the balustrades off, and we'll see pictures of that later. That was unknown. We didn't see that. You couldn't see there was a stone peak on top of it. There's a roofing behind it. So that was a big
Basically,
unknown.
picture a railing across here with
Yep.
some of these.
There's
Underneath each one.
Yep. So here's what we did. We started with that repair, the previous thing. We put that in there, and that come from an existing stone that was there to begin with on the balustrades. We just found a good part of it, cut it to like 2 to 3 inches tall, replaced it in there. You can see where we got a hole there where we'll be installing a pin. And after we did all them repairs, we installed this copper, had a roofer put the copper on that, and here he went over that Dutchman repair we did. That way it helped protect that whole thing instead of the previous one just had the roofing in the reglet joint, which allowed water to get in and create that pin to rest. Here's a picture of it being installed. Again, there's our shop drawing showing Brandy where all the pins we want to put in. And there it is up on the building where it's all being installed. So that, go back one, Justin. So this here is not just about stacking stone and stone and stone. You got to keep it level. You got to keep it straight. And some of this is what, 40 foot long? So you got to be careful, and you have to put something up there to keep that stone in place while the mortar and epoxy sets. So, you know, it gets it all set, nothing goes back together when you put these balustrade caps on. So that's very critical. Here's where we're getting into the column repairs. You can see here we got our shoring. You notice we just got one removed there. We don't want to take 2 out in a row. So we shore 2 sides, take 1 out, shore, take another stone out. And to streamline this, those are our bases down there. We had a guy on there putting them in there, squaring them up, epoxying them in. So now we can set it up when it's time. There you go, we're setting it, one already set in. You can see them 2x4s I got there. That's to help keep it in the same place it was when we removed it. That way it goes exactly where it's at. Oh, go back. You can see there's our stainless steel pin. There's my stone that you've seen in the previous thing set on top of it, and there's my column installed on top of that. And on top of that is the terracotta that we removed. We did our repair, did our glazing protection on it, and installed that back with stainless steel pins. Here's a picture of the terracotta gargoyles. After we went through them and we said, hey, these need more looked at more, it was decided, why don't we just replace them all? So they got a pretty large credit because we had a lot of money in there to repair them in place. Okay, so we give them the credit back to help them afford. Just let's put new ones in. As you can see, the cracks on that one there, you know, we could pin it and epoxy it and all that, but is it a long-term fix? It'll get you by 20, 30 years maybe, but we're looking at that while we're here and doing it now. There's what you got to do after we remove the gargoyles. We got to shore the stone up. So after we do that, we put some brick in there to keep it sealed up because there's a long lead time before I get our gargoyles back. So we put the brick in there to support the masonry above. Then we paint it so it doesn't look like red brick sticking up in the air. And then we seal around it to keep water out and weather out while we're waiting on the gargoyles. Here's another pattern of the gargoyle. That's just one. You can see we had there's three different types of gargoyles going in. You got a straight one in, an outside corner, and an inside corner. So we got to put the gargoyles in, mainly because the terracotta manufacturer makes it so it fits back in. So that's why we did these templates. We went around to each and every area and made sure that template would work so we could feel confident when we get them, we'll be able to put them in. Now is when we get into the tricky stuff. The limestone traceries, we took them all out, right? We're putting them all in. You can see on this plywood, you can see the little, where we traced around the existing stone that's going around. So we dry fit it on the ground to make sure we feel good. Now here's where, okay, it all fits in our little template. We spread it all apart again. That, you remember them plywood templates with holes in it? Here's where it's getting applied. We spread them apart, drill them, and we're going into a fit area. I don't have the luxury of dropping it on top. So we got to do what I call a blind pin. You go up on the stone above it, drill 6 to 8 inches up into it, then just drill 3 to 4 inches down on the stone below, put your epoxy in it, and epoxy on it, and get it, we hold it up to our tape or metal or something while we set it in place, pull it, that stainless steel pin drop down in the hole. We have a 3/4 inch stainless steel pin and a 1 inch hole. So that's why them templates are pretty important. And you got to get them all lined up before it's done. Yeah, here's what we ran into after we removed the heavy triple column area. The bracket that keeps that in place was deteriorated. It was hidden in the stone. So fortunately, I got a hold of a welder on site or in Covington. He come in the next day and took care of us. We talked to the structural engineer, talked to Brandy. Hey, is this repair method good? Yes, do it. We got that done within 24 hours because we're ready to build. You can see where that, remember them single columns I told you might come, that you want to take note of? They're gone here. That's where my shoring is. So we removed those single columns, 3 of them, have our scaffold company put this shoring up, because you see all that stone above it? That's all got to stay in place. So we put that shoring up, then we removed the center section up there above it, to the left. So we removed them 2 stones. Them weigh about 450, 500 pounds apiece. So we got to stick it in that set hole. So that's a job in its own. So that's important. Here's where that, my templating again. You can see here. See, we dry fit it on the ground, so I feel confident when I drag it up the roof, up 125 feet, that's going to fit. I can't say, oh man, I got to take it back down and re-drill. It's too late for that. So here we are. I got a monorail hoist, 2,000-pound hoist. It's on a monorail. It slides that whole length of the traceries. So it takes that heavy stone up, right? Then you see that chain fall. Yep. That chain fall right there. It's in the center of the piece, so that piece will slide and go centered up. And we keep that the main hoist hooked to it for safety reasons. Then we hook up that chain fall and take the weight off that main hoist so it swings back into place and we can drop it in to that pin. So then that was the easy part. This in here, that's where you better be right. Because you got them blind pins, like I said. When they drop in, you can't get them out. The only thing you got to do is cut them out, and then you're in trouble. So it takes a lot of work from our guys to do that. But here's where back to the putting the traceries in now. You can see that's our board we had on the ground, dry fitting them right there. You can see where we're using some 2x to help keep them up because it's all they're supporting each other. So while we build it, we got to keep them up there some way. So we started with that, and we evolved by using 2x6s. It was easier for us to wire it to it, keep it in place, and keep it this way so it's not shifting while we put the other pieces. Again, we're restricted by the area that we're putting these in. So Guys did a real good job, measuring twice, cutting once, installing that. Here's where we get into Dutchman's. The Dutchman is a replacing a portion of a stone instead of a whole stone. You can see here, if we were, where they're cut out, if we replace that whole long stone in that column, now I got to worry about the stone above it dropping, and it's going to be more costly and everything. So here's where we cut the Dutchman's in. We're doing it here, here, and that's where the color match comes in critical. So what we did, he's got a template of the stone we're doing. So we have 437 of them to put in around the building. So we have a couple guys going around cutting them out, using that template, putting it in there before he leaves that area. We're confident when we go epoxy and pin it in, it's going to set in that hole. That way I'm streamlining it. I don't have up and down cuts. We had a rain day. We cut 200 of them out so they're ready to put in. Pretty efficient. Okay, there's another picture of the Dutchman that you've seen earlier. That's where we patched around that. There's a picture of epoxy and patch over it that glue the stone together. So we didn't have much of all that to do on the stone cracked stones. Pinning and repointing, you can see up here on the left, that particular spire, we were cleaning, and there were low pressure cleanings, only like 400 or 500 PSI with a certain chemical, but it was moving when he was cleaning it. So he got on the phone, took a little video of it, and sent it to me. I said, just stop. So I get a hold of Randy. We got an issue here. We talked to instead of coming up with a problem, I said, here's a solution. We got with the structural engineer and Brandy. That sounds good. So we put stainless steel helical pins in there, like a 30-degree angle, and the stone below it. And then we placed all the mortar around it, and it sturdied it right up. I think we had 8 of them in there for that. Then there's a picture of us. We're removing and repointing all the mortar in the west elevation. Excuse me, the tower. So that's quite a bit of work there. So we're continually working on that. And then you see the round pinwheel, that's glazing and pointing around that. There's a picture of our guy cleaning. Here's a picture of after a week's waiting, looking to see what it looked like in the center compared to the left and right. That's what it all started out to look like. So we're not really 100% cleaning, we're spot cleaning, trying to make this building look monotone. So it blends in together. Then again, you can see the difference between before and after, and before and after. So it does make a big difference. Again, we're not using high pressure. We're using 400 to 500 PSI with the right chemical and the right dwell times and the right procedure. Okay, terracotta. Terracotta is a clay-based material that's kiln drying with a glazing material over it. So it's not a full solid unit. It's hollow. It's probably the walls are about an inch thick. So, and it's got tops and bottoms to it. So you can put a pin in it and a pin in it to go from there. The problem with terracotta, the glazing, well, alligator or spall. It's just part of the nature of it. So we go in there prep. We use a patch if needed, epoxy if needed, thin patch. That's where the glaze is just spalled, nothing's wrong with it, but you want to get the profile. So when you glaze it, what we got over here to the right, it all looks good compared to the left, to the right. And what we do is we 100% remove all the mortar joints in that before we glaze it, because you want that glazing to get into that joint a little bit. So when you point it, it's all sealed up, and it doesn't look like someone painted your terracotta. That is very critical, and we had Edison come in there and recommend what product to use, how to use it, and all that. They have various materials that do the same thing. We just wanted to feel good about them.
What's key here too is that terracotta, it's got a clay disc, which is absorbent, and it can kind of expand and contract, but it's got a ceramic glaze that cannot. So, and a ceramic glaze cannot breathe or evaporate water. So your only way that you can evaporate water out of terracotta is through your mortar joints. So we've actually seen a lot of buildings before where they've glazed the entire thing, you know, that doesn't allow it anywhere to breathe. What you end up with then is advanced, return
Yeah.
of the crazing and microfractures of that disc trying to move underneath that rigid enamel, almost like picture like a hard-boiled egg type of a situation.
Yep. Okay, there's our original schedule. Original final completion June 27th. And I'm telling everybody, if I get my terracotta, we're going to get it done this year. Weather permitting at the end of the year. It's pretty aggressive. We've manned the guys up, the crew up. I got various lifts going everywhere. I got cranes coming in to get us in spots. I feel comfortable we can do it if I get my Boston terracottas terracotta. Their gargoyles, chimeras are going to be done, but that's the last thing that's going on. First thing done, last thing going on. So it's a challenge. My foreman's up to it. He just says, if you keep me with the people coming, we'll get it done. So that's all I got.
I think we're going to let Tim wrap that up with a bow, right? It's his baby.
Yes. I don't know, I've been in construction for all my life, been with Trisco Systems for approximately 20 years. And usually going to project or progress meetings was not really a good thing to do when you're always on the defensive and somebody's worried about getting screwed over or things not going your way. But I do got to say with this project that it's a pleasure to go to the progress meeting, which is very unusual. And I think a lot of it has to do with just people trusting each other. Open communication is prime. The prepare the documents prior to this project and even up now, and also the communication of what we're seeing in the field versus what we're on the documents. I feel like the team from the cathedral, from SHP and Trisco, I just feel like it's good communication, and it's a good place to be, and it feels like a real win. So that's all I have. Thank you.
Sounds like we have 5 minutes for questions.
And before we do questions, I want to remind everyone to have our signed in to the attendance, especially like AI and also, when you do the evaluations, you can either give them to me now on this table, or you can, up at the front desk where you register, there's this drop-off.
Any questions? Good. All right. Thank you very much.